So, today, rational expressions. First off, rational expression. Rational expression is the quotient of two polynomials. Okay, anytime you see quotient, or the word quotient, they're going to look like what? A divide or fraction. Yep, that's what we're looking at. All right, these are going to kind of be ugly fractions, for lack of a better way to put it. They're going to have variables, they're going to have powers, different things like that. Okay, the one thing we have to talk about, the domain. It's a set of real numbers for which expression is defined. Domain, does it go with x's or y's? X's. Okay, it's all possible x values. Now, one thing we have to do, we have to exclude numbers from a rational expression's domain to make the denominator 0. We can't divide by 0, ever, can we?
No.
Okay, that's one of the basic rules of algebra. So the first thing we want to do, we're going to try a couple examples just excluding numbers from a domain. So which numbers would not be part of this expression? If I write this one up, I don't have any examples written on there, so you have to write the examples. So if I have this, 4 over x minus 2. The thing I can't have, I cannot have a 0 at the bottom of my fraction. So what value gives me a 0?
2. X cannot equal 2.
Yeah, x cannot equal 2. Okay? So x cannot equal 2 for that one. If I get one like this now, x squared minus 1. It's not quite as apparent right away, is it? What do I need to do to that bottom, Hoover? Thanks, Hoover. Okay, factor the bottom. So I factor this. What's this factor to be?
X minus 1, x plus 1.
X minus 1, x plus 1. So what two numbers would make this thing 0? 1 and
Negative 1.
cannot equal plus or minus 1. You with me so far?
Yeah.
Okay. I'm going to write up 2 here. Take those two and figure out which numbers you cannot have. What values can x not be? All right. So first one, what's the bottom factor to be? Anybody?
X plus 6, X minus 3.
X plus 6, X minus 3. So what values can X not be? Close. There we go. -6 and +3. Remember, what you'd have to do would have to set both of those equal to 0 and solve. Okay, so it's the opposites of those. Or you look at if I have X plus 6, what's going to make that go to 0? I have to have a -6. Okay, it's just the opposites of those. Second one, what's the factor to be? -7 plus 2. So, what values can X not be? 7 and -2. Perfect. Questions with that so far? Alright, next part. Simplifying rational expressions. This is one of those things I feel like it's very satisfying. Okay? So you're going to get a problem that looks something like this. You have x to the third plus x squared over x plus 1. Alright, so what you want to do, fact to the top, fact to the bottom, cancel out as much as you can. Okay? So what's the top of this guy factor to be? I'm pulling x squared out, right? So x squared and then x plus 1. Agreed? And then on the bottom, I still just have x plus 1. I can't really touch it, can I? See anything in common? Yep. And see, I like to do it because, like I said about it feeling satisfying, give it a little, you know? You just feel so much better when you do it. So what are you left with? X squared. I was proud earlier Friday. We were doing a problem like this in my pre-calc class, and I told him, when you do it, go shoo, shoo. And Avery Taylor was back there doing the warm-up. Now here we go. Shoo, shoo. Awesome. So I expect when we take a quiz or a test, you're not allowed to talk. You're allowed to go. Shoo, shoo. Got it? Questions on that one so far? Not bad, right? Okay. So one more here. If I have x squared plus 6x plus 5 over x squared minus 25. All right, what's the top factor to be?
X plus 1, X plus 5.
Okay. X plus 5, x plus 1. What's the bottom factor to be? X plus 5, x minus 5. Do we have anything in common? Yeah, we do. Give me a little. Okay? So what am I left with then?
X plus 1 over X plus 5.
X plus 1 over x minus 5. Right?
X minus 5.
Does that make sense? Okay? You guys try this one. Okay, x to the third plus 3x over x plus 3. It's a pretty simple one. So we factor this guy, top and bottom. What's top factor to beat?
X squared, X plus 2.
X squared, X plus 3 over X plus 3. Then what? That's right. What am I left with? X squared. Questions? Or any questions on that? Now, if I go back through and ask for restrictions, number 1, does it have any restrictions? No. We only have restrictions if there's a bottom. Okay, if there's a numerator. So this one has no restrictions. Number 3 has no restrictions. Number 2, what would the restriction be?
X cannot equal 5.
X cannot equal 5. That's it. Good so far? Give me a thumbs up if you're good so far. Okay. Now, multiplying rational expressions. This is not much different than what we just did. Okay, so when you multiply rational expressions, factor each top and bottom. So if you're multiplying two fractions together, factor the top, factor the bottom, factor the top, factor the bottom. So factor all 4 spots. Okay? Then combine it as one large fraction because it's all multiplication. And then cancel as much as possible. Okay? So let's look at one here. Look at x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. And they're not always all going to factor either. So keep that in mind as well. Now looking at this guy, the left side, x minus 7, x minus 1, it doesn't really factor, does it?
No.
No. Alright, so I'm going to make my giant fraction, and I'm going to go ahead and write those 2 in there. Okay? I'm just going to write that first 2 in because they can't factor them. Can I factor that top right?
Yeah.
Yes, what's it factor to be?
X minus 1, X plus 1.
X minus 1, x plus 1. Okay? Bottom right, does it factor?
Yeah.
What's it factor to be?
Times x minus 7.
Correct. 3 and x minus 7. So there's my big fraction. Alright, it's all multiplication, so I just smashed them all together. So from here, can I do any in?
Yeah.
Yeah. What do you see?
X minus 1 and x minus 1 and x minus 7.
Got all those? And I'm left with
X 1 over 3.
it's plus 1 over 3. Any restrictions there?
No.
Nope. Not bad, right? Multiplication is really not bad. If you can simplify a rational expression, you can do multiply them. Okay? Here's one for you guys to try. X plus 3 over x squared minus 4 times x squared minus x minus 6 over x squared 6x plus 9. Yes, I know. I'll get a the top of it. Top left doesn't change, right?
No.
X plus 3. Top right, what's it going to be?
X minus 3,
Minus 3. X plus 2. Bottom left.
X plus 2, X minus 2, and
And then bottom right.
X plus 3,
X plus 3. X plus 3. Alright. Is it time?
Yeah.
What we got?
X plus 2, X plus 2.
X plus 2 and 3. 2, 3, 2. Okay?
That's it.
Is that it?
Yeah.
Okay? So we're left with then x minus 3 over x minus 2, x plus 3. What's your restrictions?
X not equal to 2 or negative 3.
2 and negative 3. Correct. Questions so far? We're still good.
Good.
Feeling good about life?
No, not like.
Alright. Now division. Step it up a little bit. When we go division, notice, if you look at the steps for multiplication, the steps for division, there's one difference. Factor each top and bottom. Flip the second fraction, then combine as one large fraction. Remember when you were multiplying fractions way back when you first learned about it. If I had 1/2 divided by 3/4, for instance, okay, you could do the keep it, switch it, flip it, if you were taught that way, or high, low, high, right? 1 times 4 is 4, 3 times 2 is 6. Okay, either one. All right, did you guys do keep it, switch it, flip it?
Yeah.
Yeah? Okay, so this is the same concept here. Still just dividing fractions. So keep the first one, switch the second one, and we'll be good. Alright, or keep the first one, switch the sign, flip the second one. Alright, so, what the heck?
What do you do?
Where's it at? Is this there? There we go. Factor each top and bottom, flip the second one. So let's do that. So here's the first example. If I have this, x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 x plus 3. Okay? So I'm going to divide the first one by the second one here. So I'm going to keep the first one exactly the same. So I'm going to go ahead and make my giant fraction right off the bat. Top left, x squared minus 2x minus 8. What's that going to be when I factor it?
X minus 4, X plus 2.
X minus 4, x plus 2. Bottom left, x squared minus 9. What's that factor to be? X plus 3, x minus 3. Okay? So that didn't change. I just factored that left-handed fraction, correct?
Yes.
Now, the second guy, I need to flip this when I put it in my fraction. So, x plus 3 is on top. X minus 4 is on the bottom. So that just went from here to here. You alright with that? All I did was flip the second one. Now, I'm right back to the last step from before. Time to go. Okay? So what cancels?
Plus 3, minus 3.
Plus 3's minus 4's. Left with?
X plus 2, X plus 3.
Restrictions?
Equal to positive.
No positive 3. We all right with that? The only thing that changed was this right here. Okay? Alright. You guys try this one. Squared minus 2x plus 1 over x cubed plus x divided by x squared plus x minus 2 over 3x squared plus 3. Give that one a shot. Alright, so I factor this one. Factor the left-handed one. What's it factor to be? X squared minus 2x plus 1. What's that going to be?
X minus 1, x minus 1.
X minus 1, x minus 1. What's the bottom of it? X.
On the outside of x squared plus 1.
Okay. Now, on the right side, I have to factor those and flip it, right?
Yeah.
So let's start with the bottom. 3x squared plus 3. What's that factor to be?
3x squared plus 1.
Okay. The top now.
X plus 2, x minus 1.
X plus 2, x minus 1. And if you need to, guys, go ahead and rewrite this. You know, just if you want to write it again in factored form and then flip it, that's fine too. To me, I just like to factor it and flip it as I go. All right? If you need that extra step, that's perfectly fine. All right. We got any... Where we got them?
X minus 1.
Minus 1, minus 1. Okay.
X squared plus 1 and x squared.
X squared plus 1 in both of those. Anything else? No. So on top we're left with a 3 x minus 1, and on the bottom we're left with a x and an x plus 2. This is a little tougher. What two numbers can the bottom not be? What's our restrictions?
X cannot equal 0, x cannot equal negative 2.
There we go. 0 and negative 2. Okay, I think negative 2 is the easy one from what we did, but if you have just an x, you can't have 0. Questions on that? Still with me? Okay. I don't think this is terrible. Do I want to stop there?
No, you're good. Keep going.
I'm gonna stop right there.